Let's take a question based on redox reaction. In the reactions given below, identify the species undergoing oxidation and reduction. H2S gas plus Cl2 gas gives you 2HCl gas plus sulfur solid. 3Fe3O4 solid plus 8 aluminium solid gives you 9 iron solid plus 4 Fe2O3 solid. 2Na plus hydrogen gas gives you 2 sodium hydride solid. In first, H2S gas getting oxidized because a more electronegative element, chlorine, is being added to form HCl. Hydrogen has been removed from H2S, therefore also we can call it oxidation. H2S is getting oxidized to HCl and chlorine is getting reduced to chloride ion. Chlorine is gaining electron, so it is oxidizing agent. Sulfide ion are losing electron to form sulfur, so it is reducing agent. So H2S is getting oxidized or undergoing oxidation and chlorine is getting reduced, that is undergoing reduction. In next reaction, Fe3O4 is reacting with aluminium. Aluminium is acting as reducing agent, so Fe3O4 is getting reduced to iron, whereas aluminium is getting oxidized to Al2O3. Sodium is changing to sodium plus, therefore sodium is getting oxidized. Hydrogen is getting reduced because hydrogen is gaining electron to form H negative ion. So here hydrogen is acting as oxidizing agent and sodium is acting as reducing agent. Now this reaction chosen here prompts us to think in terms of another way to define redox reaction, that is in terms of oxidation number. Next we are defining oxidation number. Oxidation number denotes the oxidation state of an element in a compound ascertained according to set of rules formulated on the basis of that electron pair in a covalent bond belongs entirely to the more electronegative element. Rules for calculation of oxidation number. In elements in their free state or uncombined state or elementary state, we also call it natural state, each atom has oxidation number equal to 0. For example, H2, O2, Cl2, O3, P4, S8, sodium, magnesium, aluminium all have oxidation number 0. That is, all elements in their natural state have oxidation number 0. For ions composed of only one atom, the oxidation number is equal to charge on the ion. For example, sodium positive has got oxidation number +1, Mg2 positive has +2, ferric ion has +3, chloride ion has -1, oxide ion has -2, and so on. In their compounds, all the alkali metals have oxidation number +1 because they can lose one electron to acquire +1 charge. All alkaline earth metals have oxidation number +2 because they can lose 2 electrons to acquire +2 charge. Aluminium is regarded to have an oxidation number +3 in all its compounds because it can lose 3 electrons to acquire nearest noble gas configuration. The oxidation number of oxygen in most of the compound is -2. However, there are two kinds of exceptions here. One is in the case of peroxide and superoxides, the compounds of oxygen in which oxygen atoms are directly linked to each other. In peroxide like H2O2 hydrogen peroxide, Na2O2 sodium peroxide, each oxygen atom is assigned an oxidation number of -1. Whereas in superoxide, potassium superoxide, rubidium superoxide, each oxygen atom is assigned an oxidation number of -half. Two oxygen atoms are assigned -1. The second exception appears rarely when oxygen is bonded to fluorine. Now fluorine is more electronegative than oxygen, so oxygen difluoride, oxygen is +2 and fluorine is -1. Dioxygen difluoride, oxygen is +1 and fluoride ion is -1. So these are two exceptions in which oxygen shows positive oxidation state. The oxidation number of hydrogen is +1 in general, except when it is bonded to binary metals in binary compounds, that is in compounds containing two elements. Binary compounds means the compounds which contain two elements. For example, in lithium hydride, lithium has +1, hydrogen has -1. sodium hydride, sodium has +1 and hydrogen has -1. Similarly, in calcium hydride, calcium has +2 and hydrogen has -1 oxidation number. In all its compounds, fluorine has oxidation number of -1. Other halogens also have oxidation number of -1 when they occur as halide ion in their compounds. Chlorine, bromine and iodine, when combined with oxygen, for example in oxoacids and oxoanions, have positive oxidation number. And also in interhalogen compounds, these halogens show a positive oxidation state here or oxidation number. Here, the less electronegative element is given positive oxidation state and more electronegative element is given positive oxidation state or oxidation number. HOF is the exception, which is stable only at -40 degrees centigrade. Fluorine shows +1 oxidation number only in these compounds. The algebraic sum of the oxidation number of all the atoms in a compound must be equal to 0. In polyatomic ion, the algebraic sum of all the oxidation number of atoms of the ions must be equal to the charge on the ion. Thus, the sum of oxidation number of 3 oxygen atom and 1 carbon atom in carbonate ion must be equal to -2. These are some compounds in which oxidation number of cation is given. In sodium chloride, sodium is +1, Cl is -1. In magnesium sulfate, magnesium is +2 and sulfate is -2. In aluminium fluoride, aluminium is +3, chlorine is -1. In SiCl4, silicon is +4 and chlorine is -1. In P4O10, phosphorus is +5. In SF6, sulfur is +6. And in HClO4, chlorine is +7 oxidation state. HClO4 is called perchloric acid. SF6 is sulfur hexafluoride. This is dimer of phosphorus pentaoxide, silicon tetrachloride, aluminium fluoride, magnesium sulfate, and sodium chloride. The idea of oxidation number has been invariably applied to define oxidation, reduction, oxidizing agent, which is also called oxidant, reducing agent, which is also called reductant, and the redox reaction. To summarize, we may say that oxidation, an increase in oxidation number of element in the given substance is called oxidation, whereas decrease in oxidation number of the element in the given substance is called reduction. Oxidizing agent, a reagent which can increase the oxidation number of other element in a given substance, are called oxidizing agent or oxidants. Reducing agent, a reagent which lowers the oxidation number of an element in a given substance, those reagents are called reductants. Redox reactions are those which involve the change in oxidation number of interacting species. If any reaction does not involve change in oxidation number, it's not a redox reaction. Oxidizing agents are also called substances which can gain electron, whereas reducing agents are those substances which can lose electron. So metals are mostly reducing agents, whereas non-metals are oxidizing agents because they can gain electron to form negative ions, whereas metals can lose electron to form positive ions, therefore they are called reducing agents.